Okay, so we're going to pick up where we left off last time. We are talking about quadratic functions. So if you have the section 3.2 page, grab that. If you need a 3.2 page, I think I have them here somewhere. I have a couple left over. If you, no, that's not it. Okay, there. Anybody need a 3.2 page? So just to refresh your memory, because I know it's been a long weekend, you haven't seen me in 5 days. I'm sure you missed me terribly. So where we left off last time is, first, we reviewed graphing quadratic functions. This is how we did it when we talked about transformations. Okay, so at this point, there is nothing new. If you want to grab a piece of graph paper, if you need a section 3.2 sheet, grab them off the table. Then the second thing that I showed you last time, okay, you can see this is filled in. This is what we were talking about. The other form of the quadratic function, this is the standard form, okay, where it's not in parentheses squared. So you cannot determine the translations or anything directly from looking at the standard form. So what we started, and we kind of got 75% done last time, is being given a quadratic function that's in standard form and turning the standard form into what's called the vertex form. This right here, where I can read the translation and see what's happened, where the function has moved. And from that, in a moment, when I define it, we'll be able to determine what the vertex is of this graph. So just to, again, to reiterate, here's what we did. And we're going to, before we graph these, we're going to refresh our memory on this as well. So to turn it from the standard form, which is right here, the x squared plus 6x plus 5, into the vertex form, here was the steps. The first step we said was we grouped the terms with the x's. So you can see on my work, and maybe you have it noted on your notes, I grouped the x squared and the 6x, and then I threw the plus 5 outside. I told you to leave a blank step 2 in your notes. We would get to that. Step 3 is what's called completing the square. So what we did to complete the square is we took half the number in front of the x and then squared it. And so we added a 9 inside the parentheses. I'll get one for you in a second. Grab a piece of graph paper and I'll get you a 3.2 if you need it. And then the last thing we did was we balanced the function, so we subtracted 9 to balance out the plus 9. Now, I know it's been a while, and you probably didn't get a whole lot of practice over that over your weekend, so here's what we're going to do. We're going to start. If you don't have one, grab a piece of fresh graph paper, and what I would like you to do is for this function, this polynomial function, p of x, I would like you to complete the square on this and put it into the vertex form. And I'll put the steps right up there in case you're still copying them and don't have your notes. Here it is, x squared plus 4x minus 1. Okay, so here are the steps. I'm just going to put them on the screen. X squared plus 4x minus 1. I would like you to complete the square on that and put it in vertex form. That way we can graph it nice and easily. Bless you. Anyone else need a section 3.2 sheet? I have one more. I'm going to give you another minute or so. We're going to do another one just because I want to make sure this sinks in. This is important for your future in this unit. This is a big part of it. Okay, so for x squared plus 4x minus 1, okay, we are going to now put this in the vertex form. And here are the steps. Step number 1 is I'm going to group the x's part. So I'm going to take my p of x, and I'm going to group the x squared plus the 4x. I'm going to leave a little space and finish the parentheses, and then I'm going to put the minus 1 on the outside. That is step 1. On your notes from last time, step 2, I said leave blank. It doesn't apply just yet. Step 2 will be when we have a number in front of the x squared, but this is the simpler situation. Simple doesn't mean easy. This is the simpler situation. Okay, step 3 is the actual completing the square step. In step 3, you take half of this number in front of the x. What's half of this number in front of the x? 2, and then you square it. What do you get when you square 2? Okay, plus 4. What we've created is this trinomial is a perfect square. When I go to factor it, it's going to be the same factor times itself. We'll do that in a moment. Then the last step, step 4, is I got to balance the function because now I've added a 4. I have changed my original function. So what do I have to do out here to balance the function? Yes, if I add 4, then to keep everything in balance, I've got to subtract 4. So I'm just going to make a little note that this is so that we balance everything out. Okay, plus 4 minus 4 is 0. So I have not changed anything about the function. Okay, this is completing the square. This is relevant to your future in this unit when we're doing it with parabolas. It'll also be relevant to your future later on in the class when we find equations of circles, which is great fun as well. Now, I'm not going to do this for everyone, but I just want to show you the reason that we're doing this is now the x squared plus 4x plus 4, if I was factoring, if this was introductory algebra and we were factoring, x squared is x and x, and then what are the two factors of the last, the two factors of 4 that add up to 4? 2 and 2. It's just the number you squared a moment ago. It's plus 2 and plus 2. And so here now is my formula for the parabola in vertex form. Remember, I was given the formula in standard form. Okay, it looks just like a polynomial. Now I'm putting in vertex form so I can see the translation and I can graph it nice and easy. And so that is x plus 2 times x plus 2, or x plus 2 squared. And then minus 1 minus 4 is minus 5. We're going to do one more, and then we're going to come back. We're going to answer some questions about these 4 graphs that we have seen. But now that you've seen one worked out, and I hopefully have refreshed your memory a little bit, I would like you to do that same thing. We'll come back. We'll graph in just a moment. Here's one more, same sort of thing. I would like you to take this parabola, f of x, and it's going to be x squared minus 10x plus 27. I would like you to use the same steps we just used to write that in vertex form. All right, what I'm going to do first is I'm going to group the x's. So I'm going to take the x squared minus 10x, put them in some parentheses. I'm going to leave a little space, and then I'm going to put the plus 27 outside the parentheses. Okay, that's always step one when I go to complete the square, write this in vertex form. We're going to skip step two. Step three is now I'm going to do the actual completing the square. So now tell me, what number am I adding inside the parentheses? 5 is halfway there. You took the half of the middle. Half of 10 is 5, but then I got to square it. And so then, yes, 25. I need to add 25 right here. Okay, that's the completing the square. So again, if you don't know where that came from, that is half of that number in the middle. Doesn't matter about the negative because we're going to square it anyway, but I'll throw it in there just to be thorough. And then I square that. And that -5, when I square it, gives me 25. Last step, I've got to keep this imbalanced. So what do I do outside here by the 27 to keep my function balanced? Yep, I subtract 25. There's my balance. And now for my f of x becomes, this is now what's called vertex form because I can read the shift, which will be the vertex. I'm going to define that. It's the very next thing we're going to talk about. So now x squared minus 10x plus 25, the two factors of 25 that add up to -10 are -5 and -5. 27 minus 25 is plus 2. And there's my function. All right, we'll come back to that. I'm going to flip back over to the 3.2 sheet that we are working on. So if you were not here last time, this is where we got to. We completed the square on these two, so you can watch the very end of the video from last time that's posted on Canvas to get caught up to that. So now this is what we already hopefully remember. This was from the last test. This is translation of functions. So if I have x plus 3 squared minus 4, what two things are happening to this parabola? Where'd it go? Okay, left 3 and then down 4. That's fantastic. Well done. Thank you. Now remember, if you need to, you can draw your standard parabola. I'm going to do that right now. So I've got to take my glasses off. I got 1, 1. I got 2, 4. I got 3, 9. -1, 1. -2, 4. -3, 9. This is just my standard parabola. I'm doing this in case you need to. Hopefully by this unit, you get really, really great at drawing your standard parabola. And now I'm going to do just what I was told. I'm going to move this left 3 and down 4. So I go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. And I'm going to do that with all the points. All of them are going left 3 and down 4. And here is my new parabola that has been translated, and I'm able to see that because of the vertex form that we just did. Now I keep calling this new equation vertex form because hopefully if we've been practicing this, we can see the shift, the left 3 and the down 4. Well, this point down at the bottom of the parabola right here, this is called the vertex. And I'm going to use a letter V to denote the vertex. And basically, the way you get the vertex is just by knowing the shift of the parabola. So my vertex, my V, when I put it in a point, my left 3 means the vertex goes to -3. And then my down 4 means the vertex goes -4. That's the first bit of trivia about this. We'll come back and mention a couple other things, but what I would like you to do is the one that's right next door that last time we determined was x minus 4 squared minus 6. I would like you to graph that and write down what the vertex is, please. Okay, so this one, hopefully you wrote down this one, since there's a -4 inside the parentheses, it's going to the right 4 and then down 6. So I'm going to take the whole thing right 4 down 6. So that means when I go to define my vertex, the right 4 means what's the x coordinate of the vertex? 4. The down 6 means what's the y coordinate of the vertex? Perfect. Thank you very much. This is the information I'm going to ask for on the next test. I'm going to give you an equation like this, and these things that we talk about in these next couple minutes are the things I'm going to put a little list and I'm going to ask you for. First one, what's the vertex? Okay, and you're just going to, hopefully that's a nice simple process, and then you're going to go ahead and graph it. So I'm going to take the whole thing right 4 and then down 6 right to here, and then I'm going to move all of the points right 4 and then down 6. And my parabola is going to look like this. It's just been translated, and whee, there's my beautiful graph. So a few other things that I'm going to ask you for. Okay, these are the important characteristic traits of the parabola. Let's go into the Wayback Machine. What is the domain of my parabola? Left and right. What's the furthest left this goes? Yes, indeed, -infinity. What's the furthest right this goes? Positive infinity, great. Okay, so hopefully that's coming back to you. The range are the y values. What's the furthest down this parabola of mine goes? -4, that is true. And then what's the highest up it goes? Yep, we're doing good. If this is not coming back to you, let's talk. Okay, these are all things we talked about at the very beginning of chapter 2 when we started talking about functions. The next thing is this parabola right here, the way it is sitting. Does this parabola have a maximum value or a minimum value? When we come down to right here, the vertex, is that vertex a maximum value or a minimum value? Minimum. Minimum means lowest. Okay, it's a minimum value. It has no maximum, and the arrows keep going up forever. And so what we would say is, since this parabola is pointing upward, the ends are going up, that this has a minimum value. When you're asked about the minimum value, then you might be asked in your homework, what is that minimum value? This is going to come into play in the very last section of this unit when we come back on Wednesday, when we do what's called minimization and maximization problems. Okay, that is a use for parabolas. We're going to do very simple examples of those. The minimum value is the y value. So that minimum value is -4. The last thing that you're going to be asked, the last bit of trivia, is if you remember my basic parabola when we were talking way back, first talking about functions, we defined the parabola as an even function because it was symmetric about the y-axis. Okay, the y-axis is like the middle of the greeting card. If I fold the plane, it's symmetric. Well, now my new parabola, the blue one, is not symmetric about the y-axis anymore, but it does have a line of symmetry. Okay, so this is the other bit of trivia, the line of symmetry, meaning what is the line that the parabola is the same on both sides. And the line of symmetry just moves left or right depending on the parabola. So I'm just going to use my pencil here, or let me use the black pen for a little better contrast. This middle line right here that goes right through the vertex, that is the line that if I fold the parabola, it's the same on both sides. And so the line of symmetry, basically, it's just the x coordinate of the vertex, whatever it is. The line of symmetry is x equals -3. And those are some of the primary attributes of the parabola that I need you to be familiar with. So what I would like you to do, please, for the one on the right, I'd just like you to define those same things. What's the domain and the range? Does it have a maximum or minimum? And what is the value? And then what's the line of symmetry? All right, the domain of this, the domain of all the parabolas is negative infinity to infinity. That's probably never going to change. My range, the lowest value is -6, and then it goes up to infinity. Again, this one, since the parabola is pointing up on the ends, it has a what kind of value? Minimum. Thank you for humoring me. So it has a minimum value. And what is that minimum value? -6. And what is the equation of the line of symmetry on this one? Perfect. Well done. X equals 4. Let's do this for one more of those practice problems that we came in with. That way I can feel like I've done an adequate job getting us all caught up to what we're doing. So let's just do that for the first one, the x squared plus 4x minus 1. Here's the equation of it right there, x plus 2 squared minus 5. That's hopefully in your notes. So just go through, do all those things. Graph it, tell me what the vertex is, tell me what the domain range, max min, line of symmetry, and then we're going to move on to the next type of problem. All right, so looking at my vertex form, the x plus 2 squared minus 5, that's what we found just a few minutes ago. That tells me that this parabola has moved left 2, down 5. So that means my vertex. If I move left 2, what's the x coordinate of the vertex? -2. And then the down 5 means the y coordinate is perfect. So I'm going to go to -2 and -5 and make a dot. Now, if you're wondering about, hey, Kirkster, you seem to be pretty quick at graphing this. All I do now is I use this as I pretend this is the origin, and I do my basic points from right here. Okay, so if you can make this transition, it'll speed your life up. Okay, but if not, if you just want to do the basic graph and move everything, that's always going to work. But now, so I go over 1, 1 squared is 1. I go over 2, 2 squared is 4. I go over 3, 3 squared is 9. I go back 1, 1 squared is 1. So I'm just doing the basic points. That's why I've tried to teach you the basic points way back when, is so that you'd get really good at remembering those. And there's my graph. So then the other information, you already told me the vertex. The other information that I wanted was the domain. Domain's never going to change, -infinity to infinity. The range of this one, my lowest value there is -5. So it's -5 to infinity. This has another minimum. We'll talk about when we'll have a maximum. That's coming up in just a minute. That minimum value is -5, and the line of symmetry is x equals -2. And that's all the relevant information. Those are the things that you're responsible for letting me know about our parabola. Okay, so I feel like we're caught up now. We did some extra problems. I wanted to make sure that I wasn't leaving you hanging on those things. So now let's flip to page 2. So page 2, I give you this one, 2x squared plus 4x minus 7. And I want to do the same thing. I want to figure out what the vertex form of this is. Okay, well, going back to my steps, let's just follow along. I zoomed in a little too much, and now that we are recording, the camera won't unzoom for me. So sorry, I have to keep sliding everything around. The first thing I need to do is I need to group the terms with the x's. Great, that is absolutely no different. So I'm going to come over here to my function. I'm going to group the 2x squared plus the 4x. I'm going to leave a little space, and I'm going to put the minus 7 outside. Now we are ready, though. I know all weekend you've been wondering, what is this mysterious step 2 that he talked about and left blank? Before I can complete the square, this is super, super important. Okay, because every semester I get a handful of students, they understand completing the square, but they do it too soon. Before I can complete the square, this number in front of the x squared, I can't have that there. So what we're going to do is we're going to factor out the coefficient of the x squared. Whatever that coefficient is, whatever number's in front of x squared, you need to factor it out. And then everything else is just the way it was. So what that means is I'm going to factor out this 2. Okay, so I'm going to bring a 2 outside the parentheses. When I factor the 2 out of the 2x squared, I'm left with x squared. When I factor the 2 out of the 4x, I'm left with 2x. And then the minus 7's on the other side. Now we're ready. Woohoo! I'm going to do the completing the square step. What's half of the 2 in front of the 2x? What's half of that? 1. What do I get when I square 1? So I'm going to put 1 in here. The last step is I got to balance this. Here's the one thing I need you to notice, okay? I know before we were just taking whatever this number is, this 1, and we were subtracting it. And some of you may have already written it down, minus 1 out here, but that's not quite right. Because even though I've added 1 in the parentheses. If I was to distribute, what have I really added to this problem? What's 2 times 1? 2. So I've really added 2 to this problem. So what do I need to do out here in order to keep the balance? Subtract 2. Okay, that's important just to make sure that you know what you're doing with that number out front. Once you can get used to that, I understand that that's a little bit of a tricky step. I totally get it. Now we are ready. So I'm going to rewrite this in vertex form. So I have 2. X squared plus 2x plus 1, the 2 factors of 1 that add up to 2 are x plus 1 times x plus 1. And then negative 7, negative 2 is negative 9. There's my vertex form. The rest of this is the same thing that we've done before. And the other problems, we've got our translations and our stretching on this problem. Again, we're probably reviewing it, but it's stuff that we've seen. So what 3 things are happening to this graph when I go to graph it? Somebody tell me one of the things. Okay, all the y's are being multiplied by 2. Okay, I like that. That's a good first thing. What's next? What else is happening? Okay, it's going left 1 unit, like that. And then the other thing is, okay, it's going down 9. Excellent. So let's graph it. Then we'll give, we're only going to give the vertex and on this one because I think the other things are fairly apparent. So let's just go ahead and graph this. Now I understand with the stretching and shrinking takes us a little time. So what I'm going to do is I'm going to do my transition graph. I'm going to do the graph that's multiplied by 2 first, and then we will go ahead and we'll translate that. So what I'm going to do is I'm just going to do my basic points, remembering that I'm doubling all the y values. So right here at the origin, 0 times 2 is 0. This first point going to the right, 1 squared would be 1, but now I'm multiplying it by 2, so it's 2. The next one, 2 squared is 4, but now I'm doubling it, so it's going to be 8. The next point, 3 squared is 9, then I'm doubling it, it's 18, so it's way off the graph. I'm not going to bother with it. Going left, negative 1 squared is 1, but now I'm doubling it, it becomes 2. Negative 2 squared is 4. Now I'm doubling it, it becomes 8. So there's my stretched out graph. However you have taught yourself or reinforced for yourself how to do those stretched graphs, that's great. Always do the multiplying first. Makes life easier. And then what I'm going to do is I'm going to move this left 1 and down 9. So left 1, down 9 is right here. And then I'm going to plot my points. I'm moving all of the points left 1 and down 9. And here's my stretched out graph. The vertex of this graph, since I went left 1, the x-coordinate is -1. And since I went down 9, the y-coordinate is -9. And there's the bit of information we're going to give. All right, we're going to practice this twice. The first one, yeah, we're going to practice this twice. We've got time to do that. So let's do this. Okay, so what I would like you to do is exercise 5. I've given you another quadratic function written in standard form. First thing I'd like you to do is to write that in vertex form. And then if you have time, graph it. Bless you. Tell me what the vertex is. All right, the first thing that I'm going to do is I'm going to group those x's. So if you're still working, keep working. So 3x squared plus 12x, I'm going to throw in some parentheses. I'm going to throw the plus 6 outside the parentheses. I'm not going to worry about that. The next thing you need to notice is that I've got a number in front of the x squared, so please do not complete the square yet. If you took half of 12 and got 6 and squared it and got 36, that's going to be wrong. Okay, it's going to lead to the wrong result. So what I'm going to do is I'm going to factor the 3 out and have x squared plus 4x inside the parentheses. Leave a little space, plus 6. Now I can complete the square. Now we're ready. Half of 4 is 2. When I square 2, I get plus 4. And once again, before I make the equation balance, I got to remember that even though I've added 4 inside the parentheses, what I've really done is 3 times 4 because of the distributing property. 3 times 4 is 12, so I have to subtract 12 outside here. Now I'm ready to write this in vertex form. So I have 3. The 2 factors of 4 that add up to 4 are x plus 2 and x plus 2 squared. And then plus 6 minus 12 is -6. There's the vertex form. Now I can tell what the shift is. I'm going left 2 and down 6. We're also multiplying all the y values by 3. So there's a bunch going on this one. So again, first thing I'm going to do that multiplying. So hopefully you're getting used to doing that. So I'm going to take my basic points and I'm going to take the y values multiplying by 3. So x equal to 1. 1 squared was 1, but now I'm multiplying it by 3, so it's 3. X equals 2. 2 squared is 4, but now I'm multiplying it by 3, so it's 12. So I got to do a little guesstimating here, so sorry for the tackiness. Going backwards, negative 1 squared is 1. I'm tripling it. Negative 2 squared is 4. When I triple that, it's 12. So this is a very stretched out graph, nice and lean here. So there it is. And now I'm going to take that stretched out graph and I'm going to move it left 2 and down 6. And that'll be my finished product. So left 2, 1, 2, down 6 is right about here. And then I'm going to take the other points and I'm going to move them left 2 and down 6. And then we are going to be nice and done with this problem. Got one more for you. I'm going to leave that one on the page for just a second, in case you're still correcting anything or finishing up. Exercise 6. Now just be real careful. Notice on exercise 6, that number in front of the x squared is negative. Okay, so when you're factoring out, make sure you're careful with your signs. Okay, so give it a try. In fact, don't worry about graphing it yet. Just go ahead and complete the square, and then I'll give you some extra time to graph it when you're done. So let's just put that in vertex form. Okay, so I'm going to start completing the square on this, and then once we've done that, I'll give you another 90 seconds or 2 minutes to graph. And also on this, after we graph it, the 2 bits of information that I want that are different than the others are vertex and then maximum or minimum, what is the value? Okay, so here we go. I'm going to complete the square. So the steps are the same. Just be real careful of that negative. Negatives always kind of throw us a curveball. So first thing I'm going to do is I'm going to group those x's. So the negative 2x squared plus 12x, I'm going to put in the parentheses. I'm grouping them. And then again, because I've got a number in front of the x squared, I've got to factor that out. So here is the point of caution. When I factor the negative 2 out of negative 2x squared, I'm left with x squared. What am I left with when I factor the negative 2 out of the 12? Negative 6. Great. A negative times a negative is positive, so fantastic. Now I will complete the square. Half of 6 is 3. So what am I going to add in my gap right here? What was that? I'm sorry. Perfect. Thank you. I'm an old man. I'm hard of hearing. I appreciate your help. All right. So now, again, point of caution because of that sign. This is the first one like this. So if you goof this up, I totally understand. We're learning here. I've added 9 in parentheses. But what have I really done to the problem when I distribute? Yeah, what's negative 2 times 9? Negative 2 times 9 is a negative 18. So what do I have to do on this one for the first time to keep this one in balance? Got to add it. Yes. Got to add 18. I'm going to repeat that because I know there's some people in here, because I understand this is difficult stuff. We added the 9 in parentheses. But remember, there is a number outside the parentheses. So distributing negative 2 times 9 is negative 18. This one's different because of that negative. So we have negative 18. So to keep it in balance, that's why we add 18 out here. The rest of this, I'm now going to write this in my vertex form. The two factors of 9 that add up to negative 6 are negative 3 and negative 3. Negative 13 plus 18 is plus 5. So here's what I want you to do. This is the grand finale of page 2. I would like you to graph that, noting the negative, okay, and what that's going to do to my graph, and then write down what the vertex is, and then is there a minimum or a maximum, and what is that value? That's what I thought. Because I'm going to get started. First thing I'm going to do a transition graph where everything is multiplied by negative 2. So this is going to be in pencil. I'm multiplying everything, my basic points, by negative 2. So right here in the middle, 0 times negative 2 stays 0. Again, when I go over 1, 1 squared is 1, but now I'm multiplying it by negative 2, so it becomes negative 2. 2 squared is 4. When I multiply that by negative 2, I get negative 8. 3 squared would be 9, so 9 times negative 2 would be negative 18, so way down on the desk. So I'm going to leave that point off. Same thing the other direction. -1 squared is 1. When I multiply that by -2, I get -2. And then -2 squared is 4. When I multiply that by -2, I get -8. So here is the graph that's multiplied by -2. That's not my final graph. That's just my transition. Now I'm going to take that. I'm moving everything right 3, up 5. So right 3, 1, 2, 3, up 5, boom, right there. And then I do my basic points that we just saw on the pencil graph. And here is my graph that has been stretched by a factor of -2 and has been shifted. So the vertex, since I went right 3, what's the x coordinate of the vertex? 3. Since I went up 5, what's the y coordinate of the vertex? Yeah, that sounds great. This time, for the first time, my parabola, notice, is pointing downward. Okay, the wings of it are going down. So does this one have a maximum or a minimum value? This time we come up to the maximum. It looks like a hill, so it has a maximum value. And what is that maximum value that we have on this problem right here? 5, yes. When you are asked about the maximum value, the value is the y value. That is what's being referred to. Okay, excellent job. I know that that's difficult stuff. I think that that's the most difficult. This is the most difficult part of Unit B. We talked about complex numbers. I think most of that was stuff you've seen before. Now we're going to finish out just 2 quick more problems here. Sometimes when you're working with parabolas, when you've actually maximized something or minimized something, if you're using parabolas in some application, you're not really concerned about the graph. You're not concerned about what you're really just concerned about is what the vertex is, because all the fun of the parabola is happening at the vertex. And sometimes the numbers, if you got fractions and decimals, it's going to be too hard to put it in the vertex form. So what we have here is what's called the vertex formula. If I just want the vertex of the parabola, okay, I don't care about any other information but the vertex. Here's how you find the vertex using the vertex formula. Okay, the vertex of the graph of my parabola, ax squared plus bx plus c, that's the standard form, is given by the following point. Okay, so the vertex v, the x coordinate of the point is given by this. It's -b over 2a. B is the value right in front of the x. A is the value in front of the x squared. The y coordinate, now this is going to look complicated, and I'm sorry that it looks grosser than it really is. Basically, the long and short of it is you then take that x value and you plug it into the parabola to get the y value. Okay, and the way that looks with your notation is I've got my p with -b over 2a plugged in. Okay, so that's just the fancy notation to say find the y value once you know the x value. So I'm going to do example 3. I'm going to apply the vertex formula. We're going to answer the question, does this parabola have a maximum or minimum value, and what is it? Then I've got one for you, and then we're done with this section right here. And we're going to do a very little bit of the next section I gave you the sheet for. Just basically a lot of the next section is review of some intermediate algebra stuff. So, so hopefully memories get triggered there. All right, so here we go. My parabola is 2x squared minus 4x plus 5. I want to know what the vertex is. That's what my goal is. So first, I will find the x coordinate of the vertex by using -b over 2a. First question, what is the value of b of this right here? What's the value of b right here? -4. So I want -b. I'll write this down this time. I don't want to lose anybody. So it's -4, which of course 2 negatives are going to make a +4. What's the value of a of this parabola? 2. So in the bottom, I'm going to have 2 times 2. So I've got the b value is -4. The a value is 2. And the formula for the x coordinate of the vertex is -b over 2a. So in the top, that means I have 4. In the bottom, I have 4. So the x coordinate of the vertex is 1. So if you'll allow me, I should have left a little bit more of a gap there. I'm just going to write my v for vertex right here, and the x coordinate is 1. To find the y value, I just take this x value of 1 and I'm just going to plug it in. That's all. So I've got 2 times 1 squared minus 4 times 1 plus 5. I've just put the 1 into my equation. 2 times 1 squared is 2. Negative 4 times 1 is negative 4, and then plus 5. 2 minus 4 is negative 2, plus 5 is 3. So the y value is 3. There's my vertex. I've kept the number simple. I'm not trying to, I know this is new stuff, and I'm not trying to confound you. I'm avoiding decimals, things like that, just because I want you to get used to using these things, okay? So now, looking at this parabola, do you think this parabola is going to have a maximum value or a minimum value? Why do you say minimum? That is 100% correct. How do you know this? How do you know this parabola is pointing up and it's going to have a minimum value? The A is positive. Yes, the A is positive. It means it's pointing up. So that means I have a minimum value. And then what is that minimum value? Yep, just the y value of the vertex. Okay, that's what we saw on the previous graphs. If you flip over on your sheet at the very front page when we were determining minimum values, it was just the y value of the vertex. All right, your last problem from section 3.2, exercise 8. Go ahead and determine the vertex of that parabola right there, and then minimum, maximum value. All right, my x coordinate of the vertex is always given by negative b over 2a. So on this particular problem, the b value is negative 6, so that's negative 6 over 2 times a, and that's 2 times negative 2. So once you know where those values are, these are just plug and chug problems. Negative 6 is 6, 2 times negative 2 is negative 4. And that is negative 3 over 2 or negative 1.5. I guess I must have made a little mistake. I didn't mean to do a fraction, so my apologies for that, but we'll struggle through. So the vertex here is negative 3 over 2 or negative 1.5, whatever your pleasure is right there. And now I'm going to plug that into my function. So I've got negative 2 times negative 3 over 2 squared minus 6 times negative 3 over 2 minus 5. So that's negative 3 over 2 times negative 3 over 2 is 9 over 4. Or if you're using decimals, that's 2.25. Here, a negative times a negative is positive. 6 times 3 is 18. 18 divided by 2 is 9. Well, at least that's positive. We get rid of that fraction somehow. When I take negative 2 times 9 over 4, that's a negative times a positive, so that's a negative number. And then 2 goes into 4 and leaves 2, so I have negative 9 halves. 9 minus 5 is plus 4. Common denominator is 2, so 4 is 8 halves. 8 divided by 2 is 4. If you struggle with common denominators, I got a video that can help you a little bit, so let me know. So we end up with negative 1/2. Okay, so there's a little bit of arithmetic. Sorry, I know it's Monday, shouldn't do that to you. Last little bit. Does this parabola, does it have a maximum or a minimum? Maximum. How do I know this one's pointing downward? So I have a maximum. The A is negative, negative 2. Perfect. So that means this is pointing down. So I have a maximum value. And then the maximum value is always the Y value. So it's negative 1/2. And there you go.